It's Monday, December 8th, and it's way too cold to go out, so I'm doing a video on the rank size rule in US megaregions. So this is going to be quick, related to my thesis work. Just wanted to share how exciting it is to finally have the ability to take a map like we're looking at here from 2008. This is coming from the Regional Plan Association as part of their America 2050 initiative, and finally recreate this in my own GIS and be able to explore that with an actual understanding of some of the basic foundational geographic rules and theories that have been established and have been more or less proven to dictate how our complex societies and civilization kind of functions in an urbanized way. So what we're looking at here is a list of the cities in the United States ranked by their population. And if you notice in the chart, there's a straight line there with an R-squared value of 0.99, which is extremely strong. Even though New York City and some of the largest cities form outliers on the line, as we get closer to the right side of the chart, the smaller cities, they basically fall right on that line exactly. This, even though I had read and understood the rank size rule, seeing it in the data that I've been working with really amazed me, because it's the pattern behind the complexity that we experience in our everyday lives, traveling around and wandering around in cities and not being able to understand that thousands and millions of individual decisions actually create something of a very structural, organized pattern when we aggregate it like this. So what we're looking at is the U.S. major cities data set coming from Esri's Living Atlas of the World, and we're looking at the rank size rule breakdown of those cities, and we're going to jump into the living map of those US megaregions and explore this rank size rule megaregion by megaregion. Now, this is coming from really one of the most influential papers in geography in the 20th century, or at least in my limited view, Cities as Systems Within Systems of Cities by Dr. Brian Barry from the University of Chicago. And right at the beginning of the paper, he calls out that rank size rule from GK-ZIPF and provides a formula. And I spent an hour this morning understanding what that formula is, and I'd like to share that with you now and then share some examples and hopefully communicate some of my own excitement at realizing what this means and what it could mean for my research going forward. So here at the bottom of the page, distribution of city sizes, a formula is given that breaks down how this rank size rule works. So let me quickly stumble through what the formula means, and then we'll jump right into the live real world examples. So here it is, rank size rule. The population of any city in that ranked list is equal to the population of the largest or first ranking city divided by the rank squared. And we can look at this in logarithmic form, where that population of the city of rank R, the log of the population of that city of rank R, is equal to the log of the population of the largest or first ranking city minus Q, which is a constant, meaning that in the perfect ideal world, this is 1, where the cities line up exactly. First, second is half as large, third is large. It's not that perfect, as you've already seen in the complete US cities breakdown, but it's really close and really fascinating. And this rank size rule gives us another tool to look at regional breakdowns and how well are we drawing a line around a functioning urban system comprising a megaregion. So let's jump right into ArcGIS Pro and take a look at what I like to call the living map of these US megaregions. I mean, to have a map that, in my youth was really influential, now I've been able to bring it to life and explore it here in GIS, and it's really a wonderful thing. So let's start with that list that I began with. This is the overall list of all cities in the United States. I have the data set added to the map, and I've organized these cities by megaregion, loosely following the symbology of that RPA map where the megaregions are defined in different colors. And if we zoom into any one in particular, we can see the cities symbolized proportionally by their population. So let's do a quick overall look of all the US cities. And apologies that I don't have labels on my map, but just keep in mind I'm loosely following this map from the RPA. I've gotten rid of the Gulf Coast megaregion because that just did not develop as was predicted in 2008. We're looking at 2020 population totals, so 10 megaregions across the entire country. This is the full overall list, again with that extremely strong R-squared value of 0.99, starting with New York, obviously the biggest, and as I select the city in the list, you'll see it highlight in the chart. So New York, Los Angeles, Chicago, Houston, Phoenix. Each one of these top cities in the list creates the top city in one of the megaregions until we get to Philadelphia, as that falls within the Northeast and is secondary to New York. Same thing, San Antonio, San Diego. So really these top 5 cities in the country are the largest cities in their respective megaregions. So let's take a look at these very quickly. Don't take too long here, but I'm pretty amazed with what I found. So interestingly enough, Southern California, and I'm including Las Vegas in this as well, actually has the weakest R-squared of all the megaregions. We've got this Los Angeles, which is right on the line, and then San Diego falls below the line. Same thing with Vegas, same thing with Long Beach, and this pattern where the largest cities in Southern California fall below the line, and then the smaller cities actually fall above the line. So what that means is that the ranked cities kind of are smaller than anticipated, and the smaller cities are larger than anticipated. So there's a lot of things that we could probably look into here. Is this a cohesive urban system? I think if we dropped Vegas, we would have a higher R-squared. And this is why this is so much fun, because we're kind of validating and evaluating the megaregions by another definition, for which a methodology is provided to compare and contrast, and I've already done all that. But we can also take a look at these cities as systems within systems of cities, look at that R-squared value and say, okay, is this an expected rank size distribution, or are the boundaries incorrect? Could we refine these boundaries better? Is there something to look at further into this? So that's kind of the spirit that we're looking at this in. So we'll continue to move on. Northern California is pretty interesting in that San Jose is the largest city in the Bay Area, but falls again off the line. Our R-squared here is 0.94. So we've got San Jose, San Francisco, Fresno, Sacramento, Oakland, Stockton, Reno, Fremont, all below the line, and then the smaller cities go above the line. So this is like a California thing. It's pretty interesting. The Bay Area is really like one big super city. You know, we've got San Francisco, the financial, tourism, now the AI tech hub, San Jose, of course, the Silicon Valley, the traditional tech center of the universe, and then Oakland, the port city, more working class. Everybody has to cross the bridge to get to their service jobs in San Francisco. So it's an interesting area to look at, but I started with the two worst examples for adherence to the rule. California is fascinating, and for a variety of reasons, but one of which is how these urban systems work, function, and should we draw different boundaries? And do boundaries even matter? That's a question we always have to keep in mind when doing regional geography is, are we drawing lines that don't really exist around places that don't matter, don't solve a problem? Possibly. So let's jump across the country here. Instead of focusing on Cascadia, I want to jump to the original urban megaregion, the Northeast. And show that its distribution is far stronger, far closer to adhering to that rank size rule. So New York, the big outlier, well above the line. Same thing for Philadelphia. And then Washington, right on the line. Boston, Baltimore, Newark, New Jersey, below the line. But you can see it's a very different pattern than what we saw on the West Coast in California. Now, the Northeast is probably the most established megaregion in terms of geography. There's not, to my knowledge, a comparison to Jean Gottman's 800-page Megalopolis, the urbanized northeastern seaboard of the United States, which really defined that term megaregion and did a deep French-style, comprehensive historical observational geography on this region. And this book was cited by, for example, Senator Claiborne Pell, who wrote a book, Megalopolis Unbound, that advocated for the creation of high-speed passenger rail. That eventually led to the creation of Amtrak in 1970, which is something I'm really interested in, is how can we create works that can be used to advance policies and can be used by other people in other disciplines and even other geographers. That's kind of the intent here. So that's the Northeast. Let's move on to the next big urban megaregion, always difficult to define, the Great Lakes. And I hope I have my table open. All right, no table for the Great Lakes, but we'll just say Chicago, number one, obviously, followed by, and this was a surprise, Columbus, Ohio. That's probably because the Twin Cities is broken down, but still 0.99 r squared for the Great Lakes. So that would suggest that it's a cohesive urban system, cohesive system of cities within systems of cities that would be comparable to a nation state, for example. So let's move on to the next one, which is probably the most controversial megaregional definition that I'm working with. I already got rid of the Gulf Coast, but I lived in Colorado for 7 years. Never ever experienced the connection with New Mexico that this map and these boundaries imply. Basically, from Pueblo all the way down to Santa Fe, it's extremely rural. I-25 corridor. So that may explain why we're a little all over the place with the Front Range cities' rank size distribution. Our largest city, Denver, kind of off the line. Albuquerque, Colorado Springs, Aurora, suburb of Denver. Fort Collins, my favorite town, lived there for 3 years. But this is when I had the idea, hey, maybe I could use this rank size rule distribution to validate the megaregional boundaries in the cities within. Because if it looks skewed like this, and like we've observed in California, there may be some additional work to do in terms of accurately capturing and defining these systems. Next up is Florida. Florida is the fastest growing megaregion, possible exception of Texas. And Jacksonville, everyone kind of forgets about Jacksonville. It's enormous. Almost 1 million people, followed by Miami, Tampa, and Orlando. Pretty strong R squared of 0.96, but all the big cities are below the line, and then similar to that trend we see in California, the smaller cities are above the line. So this might be something to look at in terms of more recently developed urban areas, but a lot more to look into regarding that. Moving on from Florida to Cascadia, back up to the Pacific Northwest. This one nailed it, and it's again, this is another region that I'm probably going to break into two in my work because of this rural stretch in between the Seattle-Tacoma area up here and the Willamette Valley Portland zone. But 0.99 r squared, this just fascinates me. I mean, we look at all the cities in this Cascadia region, and even though Seattle a little bit below, Portland a little bit above, they start to break down very regularly until we get these points just lined up right on that straight line. Meaning that we organize our settlements into major cities, secondary cities, tertiary cities, and then networks of smaller towns and cities out from that. Uh, Almost regardless of the geographical barriers or boundaries, like we've got massive mountain ranges, islands, Puget Sound, the international boundary with Canada, yet we can draw a boundary, rank the cities by population, and see this rank size rule clearly demonstrated. It it got me really excited this morning. I might be the only one, but it's one of those times where you learn a theory, learn a equation, look at the data that you've created and worked with, and say, "Wow, there it is." You know, it's been hiding behind the data and the variables I've been working with this whole time. And again, for the Piedmont Atlantic, nails it. Now, what's interesting here is Charlotte, within the city limits, is actually a lot bigger than Atlanta, which is kind of counterintuitive because I always viewed the Atlanta as being the primary city within this Piedmont Atlantic region. So the actual boundary of the city that's being used to define the population value that then gets put in the ranked list is very important. And there's lots of directions that goes in Barry's paper and far beyond within the discipline of geography. However, we take a layer, this USA major cities layer from the Esri Living Atlas that's been compiled by professionals using census data according to standard rules, and here we go. 0.99 for the entire country, 0.99 R squared for the Piedmont Atlantic. It's really remarkable if you think about how these even distributions really don't change across the country and even around the world. So the Arizona Sun Corridor, Arizona, from Phoenix to Tucson, again, very strong R squared. Even though many of these large cities like Glendale, Scottsdale, Mesa are just suburbs of Phoenix, they still adhere rather tightly to that line and only get more so as we get further to the right on that chart. So finally, we're going to end with the Texas Triangle and take a look at Houston, San Antonio, Dallas, Austin, Fort Worth. As you can see, similar to the other mega regions, more divergence, more variance toward the left-hand side of the chart, and things getting more and more focused and aligned towards the right-hand side. But again, 0.99. Now, what I'll end with is, you might be wondering, well, what other pattern could it possibly be? Right? Well, it could be lots of things. There's an inherent logic to the grouping and organization of human settlement that we understand intuitively, but when we look at it from a kind of a data science perspective, I'm such a novice, I shouldn't really ever say data science. When we look at it, in a GIS software program, it's remarkable how organized it is. So even though, looking at Texas, Houston, where they don't even have zoning, it's something. It makes you think that there's something behind the phenomena that we experience in our everyday lives, or that we look at when we read a map or something like that. That there's these powerful rules that perhaps we could use to predict things and gain a competitive advantage in business or whatever else we're looking to do going forward. But I think really that's the excitement of learning, of going back to school, of trying to understand science, is that you get that sense that there's something there. And I think that's what Brian Barry felt when he wrote that paper back in 1964 and inspired him to continue on that quantitative path. But I think that's what inspires a lot of us in the discipline, is we don't exactly know what it is or why, but we've seen enough of the organization, of the patterns behind our civilization, our societal spread and culture as the human species on the surface of the earth, that there's almost kind of a hidden force at play. And the rank size rule is an excellent introduction to that because it's simple, it's straightforward, it doesn't just work for urban geography, population distributions, it applies in many places. But the excitement of seeing it there, so glaringly obvious in your own data, is really remarkable. So that does it for the the video. I hope this was useful in some way. Thanks so much for watching, and I'll see you in the next video.